Hey guys, it's Miss Johnson here, and we are here for the second to last video of Unit 9 of your whole algebra. We are on Unit 9, Note 6, which is doing long division with polynomials. Our lesson objectives for today are I can simplify rational expressions, and I can divide polynomials using long division. So we're just going to take a little trip down memory lane and revisit our old friend long division. Now, we all know that we can take something like this, 3,240 divided by 15, and plug it into our calculator, which is great, and that's a wonderful tool to have, but just to do a little revisiting, we're going to practice long division or just have a little review of it. So remember with long division, I'm going to take the top number, 3,240, and I'm going to divide it by, put it inside the box, divide it by 15, put 15 outside the box. And now I need to figure out, can 15 go into 3? It doesn't, so then I need to look at the next number. Can 15 go into 32? Yes, it can, and it can go in 2 times. So I'm going to put a 2 up there, and I multiply. 2 times 15 is 30. Subtract, 32 minus 30 is 2. And I do it again, bring down the 4. So now I'm looking, can 15 go into 24? And yes, it can. It can go in 1 time. So I put a 1 up there, multiply. 1 times 15 is 15. Subtract. I have 9 left over. Do it one more time for the 0. And in this case, can 15 go into 90? Yes, it does. It goes in 6 times. And 6 times 15 is 90. So I have no remainder. So my quotient here is 216. So that's just revisiting the concept of long division because we're going to be doing that today with polynomials. I want you to see if you can remember long division and complete number 2 on your own. Let's look at number 3. Now we're just going to simplify rational expressions that only have monomials in the bottom, meaning there's only one term. So this is only one term. When there's only one term in the bottom, I really just need to split up the 3 different fractions. I have 3 terms on the top and only one term on the bottom. So I'm going to write those as 3 different fractions. I have 12a to the 5th divided by 6a. Minus 3a squared divided by 6a plus 42a divided by 6a. And I'm just going to reduce each one of those as I can. I can take 12 and divide it by 6 and I get 2. And a to the 5th over a, that a is going to go away and it leaves me with a to the 4th. So the first term I have 2 times a to the 4th. Then in the second term I can reduce 3 over 6. That's going to be a 1. That's going to be a 2. And a squared over a, this a can go away, that's going to be a to the 1st. So the second one is still a fraction that looks like a over 2, which is fine, we can leave it like that. And then the last one, 42 and 6 have a common factor of 6, that's going to be 7, that cancels out, and a over a cancels out, so I'm left with just 7. Now I always take one last look to see if there's anything else I can simplify. Since this term is a to the 4th, that term is just a to the 1st, and that term has no a, there's nothing else I can do to simplify those, so I'm going to leave it as it is. I'm going to get you started in number 4, and then I want you to finish it. So I'm going to change these and write them as 3 different fractions. 15x to the 4th over 5x minus 35x to the 3rd over 5x plus 20x over 5x. Okay, so I want you to simplify each one of those and see what you get for a quotient. Now let's talk about long division with polynomials. Long division. So the steps for long division with polynomials are the same as the steps for just dividing numbers using long division. The first thing I do is set up the box. The denominator, or the bottom, the divisor it's called, goes on the outside. The dividend goes on the inside. Then I'm going to find a number to multiply the divisor by to get the dividend. After I do that, I multiply by all parts of the divisor and subtract, and then I'm going to repeat each time until I reach the end of the question. So let's try number 5 together. In number 5, now I'm using long division, okay? So I'm going to set up my box. Leave yourself a little bit of space above your box because we know we're going to have to write the quotient up there. So I left a little space. The outside of my box is x plus 5. That's the dividend. I'm sorry, that's the divisor. And the inside of my box is x squared minus 3x minus 40. That's the dividend. So the first number goes inside, the second number goes outside. Now, here's what you have to ask yourself. You're looking at the first part. I'm looking at this x. And the question is, what do I need to multiply that x by to get x squared? I'll say it again. What do I multiply x by to get x squared? If I want x to look like x squared, that means I need to multiply by x. And if I'm multiplying by x, then it goes above the x term. So that's the first number that I'm going to have in my quotient. Okay? And now I divide just like I would, I multiply just like I would with regular long division. I need to multiply by that. So x times x gives me x squared. Notice that it's lined up under my squared term. And multiply by the other part. X times 5 is 5x. Okay, so I took the number that I found, in this case it was an x, and I multiplied it by both parts outside. Now I'm going to subtract, and this is where people make mistakes. We have to be careful to subtract the whole thing. I always put this in parentheses and put my subtraction outside, because then you ask yourself, x squared minus x squared, that's going to be 0. Then I have negative 3x minus 5x. Negative 3 minus 5 is negative 8. So this is negative 8x. Okay, be careful to subtract both parts. So I'm done with the first round. Now I need to do it again. So I'm going to bring the 40 down. And this is the new thing that I'm trying to fit it into. I want x to look like negative 8x. In order to get x to look like negative 8x, I need to multiply by negative 8. So I'm going to have a negative 8 out front, do negative 8 times x, and then I multiply by both. Negative 8 times x is negative 8x. Negative 8 times 5 is negative 40. And again, we're subtracting both parts. So I have negative 8 minus negative 8. Well, we all know that minus and negative is plus. So negative 8 plus 8 is 0. Okay? And then the negative 40 minus negative 40, same thing. That's plus a positive, so I also end up with 0. Now this is good because that means I have no remainder. If I have no remainder, then this is my quotient. My quotient is simply x minus 8. Okay. Now it's tricky because we're thinking of polynomials instead of just plain numbers, so it does take a little bit of effort. Okay. Let's try one more together. X squared minus 9x minus 10 divided by x plus 1. So again, the second number, that x plus 1 goes on the outside. I'm going to make my box and put x squared minus 9x minus 10 on the inside. Okay, now you have to ask yourself, how do you make x look like x squared? Well, I need to multiply x by x to get x squared. So I'm going to have an x up there. Since it's an x, I'm lining it up in front of the x, or above the x term. And now you multiply. So this goes to that, and it goes to that. I have x times x, which is x squared. And I have x times 1, which is x, and subtract. X squared minus x squared is 0. Negative 9x minus x, that's negative 9 minus 1, negative 10. Okay, so I'm done with that part. I need to bring down the negative 10 and try it again. I want you to see if you can finish this question on your own and get to the end of the quotient there. And that'll be the end of our video for today. And you can go on and take your Schoology quiz, and we'll see you all tomorrow. Thanks for watching.